Hello and welcome to another episode of the EnVisioneering Exchange, the podcast where industry leaders discuss the most important topics in building and urban efficiency. I'm your host, John Sheff, Danfoss's Director of Public and Industry Affairs. Now, you can subscribe to our show on Apple Podcasts, Spotify, SoundCloud, or wherever it is you get your podcasts. And today, I am thrilled to be joined by Jeff Tucker, Danfoss's Global Head of Microchannel Heat Exchangers. Jeff brings more than 10 years of expertise in the industry and is a wealth of information about this important topic. So, Jeff, thanks so much for joining us.
Thank you for the opportunity. Appreciate it.
Yeah, no problem. Let's jump right in. So heat exchangers are, of course, a vital piece of any large HVAC installation, but I don't think a lot is known about them. Tell us, what are the various types of heat exchangers on the market and what's used in HVAC and why microchannel technology is a good fit?
Yeah, so when we talk about microchannel, or we talk about heat exchangers in general, that's a very large umbrella term. So there are many different types of heat exchangers out on the market. Obviously, as the name implies, the purpose of a heat exchanger is to transfer heat from one medium to another medium. So in many cases, the medium is refrigerant, and the other medium could be water, could be another refrigerant, or could be air. So, a very, very common, actually the most common type of heat exchanger is transferring heat between oftentimes refrigerant and air. So we see those types of heat exchangers all over the world, especially in North America. Very popular way to transfer heat is to an airside heat exchanger. Most people have that on the side of their house, the little unit that sits outside with the fan blowing. It's moving air across the heat exchanger, and the heat exchanger is what typically makes up the bulk of the product. So what we're talking about with microchannel is actually a airside heat exchanger. So it's Danfoss provides many different kinds, but microchannel is specifically for airside. So we're using air as a heat transfer medium. And microchannel is a little bit different than what has traditionally been sold on the market. If you look back at airside heat exchangers from even 100 years ago, you'll see, the old round copper tube, aluminum plate fin type heat exchangers. Those have been around a very, very long time. I kind of refer to those as the incandescent light bulb of heat exchangers. So they've been around, they're reliable, they do the job, people are familiar with them. But just like the incandescent light bulb, they've kind of started to be phased out. People see the benefits of getting higher efficiency from new LED light bulbs and things like that, which is kind of how I would describe microchannel heat exchangers. Yeah, so again, that's kind of why what we're focused on with microchannel and why we're introducing it into the market to meet some of the growing efficiency needs and other green initiatives.
When we talk about microchannel, just explain the technology, how it differs from that traditional heat exchanger, and what are the environmental benefits, what are the efficiency benefits?
If we talk about the traditional, the old round tube plate fin, when we talk about those, there are certain characteristics to that heat exchanger. One is that it's relatively large. It uses different types of materials, copper, aluminum, often. So you have a mixture of different types of materials. It has a fairly large internal volume, which you have to fill with refrigerant, and refrigerant is not necessarily environmentally friendly. So when we talk about moving to microchannel, microchannel is a completely aluminum product, so we don't have mixtures of different materials. So at the end of its life, when there's a need for recycling the product, it's very easy to recycle microchannel because it's aluminum. Aluminum is very abundant and very easy to recycle. And because it is a very high efficiency product, you're often able to meet the same level of performance compared to tube and fin with a much smaller heat exchanger. So that means that the product itself is smaller, it's lighter, its internal volume is much lower compared to tube and fin, which means it uses less refrigerant. So using less refrigerant is also very environmentally friendly. And then, we've heard a lot of things about supply chain and shipping things from one place to another, storing things in a warehouse. Anytime you can reduce the weight of a product, reduce the size of a product, and make the shipping and storage more efficient, then of course that's going to be good for the environment as well. So it's really a great product in the sense that it achieves all the higher performance targets that are becoming more of a requirement for HVAC products, but it's also doing it in a very green way by being smaller and lighter, more recyclable, and using less refrigerant.
Yeah, I mean, you hit some really key benefits there. Not only, we talked about the environmental benefits, but about the benefits for OEMs and our customers, right? You can reduce charge size with your refrigerants, and as we go into move into the future, the next couple of years, and some of these regulations are coming out. We move to SEER 2 for residential air conditioning. We move to IEER for packaged rooftops. And some of these products, you're going to have to cram more efficiency into a smaller footprint, and reducing the size of a heat exchanger can make a huge difference for OEMs, right?
Absolutely. I mean, it's really going to be key to making sure that the products that are being sold will fit into the spaces that have traditionally been used.
Absolutely.
For the older technology. So the challenges are in the future not having space available, especially when you retrofit products. Our OEMs are developing products that have to retrofit into a space that's already been defined. And in order to remove the old product and put a new one in, and the new one may be twice as efficient, but it obviously can't be twice as large as the old product. So keeping the product at a smaller size has tremendous advantages to our customers.
Now, tell me a little bit about what makes the Danfoss microchannel unique for HVAC.
So, we're a very technology-driven company. When we talk about heat exchangers, and specifically microchannel heat exchangers, we are constantly developing new products that we're able to achieve certain things with microchannel that we couldn't do with tube and fin. And then in other cases where we're able to do the same things we were able to do with tube and fin, but in a much more efficient way, or much more higher performance and efficiency for the end product. So some of the things that we've been working on, a product it's called interlaced product. An interlaced product is where a system, in order to achieve higher efficiencies, it actually operates in two different stages. So it can have a low speed or a medium speed, or when those two things run, those two circuits run at the same time, it could be a high speed. So you actually have two refrigerant systems in one box. So there's two compressors; they operate independently. And what we're able to do is we're able to use an entire heat exchanger surface, whether you're using low or medium or high. We can do all of that with one heat exchanger surface by having unique ways of designing and developing the microchannel heat exchanger. It's kind of a little bit complex, but I think most people who use these types of heat exchangers, they understand the term interlaced, so they would know what I'm talking about. We're also able, traditionally a tube and fin heat exchanger is usually a square or a rectangle. With microchannel, we're actually able to make special shapes. So there are lots of applications that our customers have developed where the end product, it might have a piece of sheet metal that covers, the blocks off where the heat exchangers are to keep air from flowing into the end of the heat exchanger assembly. We're actually able to design microchannel products that can be a special shape. So they're not square, they're not rectangle, but where they would traditionally have a sheet metal block off, we can replace that with an actual heat exchanger. So what's interesting about that is it doesn't make the product larger. It makes it the exact same size as it was before, but we take sheet metal away, we add heat exchanger in. So having more heat exchangers in the system allows them to have a much higher performance, higher efficiency product. So that's something that's kind of unique to microchannel, and something that only Danfoss does with these special shapes. And then, of course, with new refrigerants, we're able to quickly adapt to new refrigerants. There's a lot of low density refrigerants that are coming out now, especially for commercial type equipment. It's very easy for us to manage the changes in those refrigerants with microchannel. They're much more flexible than the old tube and fin type product. And Danfoss has been developing new technologies to meet those demands for different refrigerants. And really, the one thing that I'd like to talk a little bit more about, we're also developing a next generation evaporator, which is pretty exciting for us.
Yeah, I mean, tell us a little bit about that next generation evaporator. And you also hit on a key point here for microchannel. I think the idea of surface area and being able to get more surface area in to a confined space is really what makes the whole thing work, right?
Yeah. So the easiest way to improve performance with a heat exchanger is just make it bigger, right? So if you have more surface area, you're going to get better performance. So that's always the easy way to do it. But as we talked about earlier, sometimes that's not really an option, and it's not really desired to make a product bigger because typically bigger means more expensive. So keeping a product small is important. So absolutely, any place we can put a heat transfer surface without enlarging the size of the end product is super, super important. Um, but as we touch on the next generation evaporator, as you ask about, um, there are some challenges when you take microchannel and you want to replace a tube and fin product with a microchannel heat exchanger. And one of the challenges that we've seen in the initial designs were refrigerant distribution. So when you're operating a heat exchanger, one of the key factors in its performance is the ability to distribute the refrigerant evenly within the heat exchanger, so that the heat exchanger is working, in all areas of the heat exchanger, is doing the same amount of work to provide heat transfer. So oftentimes in most of our customers' applications, they do the best job that they can to try to make the air that's moving across the heat exchanger, to try to make that as evenly distributed as possible. But it's sometimes really difficult to do. So we see a lot of air maldistribution. So in the traditional heat evaporator, indoor evaporator design that's been used with microchannel, that is available on the market, we see a lot of iterations that the customer has to go through in order to achieve their performance targets. So they'll install a microchannel evaporator, they'll run a test, we'll have to make some adjustments, they'll run another test. And all these iterations, of course, are time consuming, expensive.
Mm-hmm.
Lab time is very difficult to come by. So having a technology that allows a customer to do that much more quickly and much more efficiently is super important. So our next generation evaporator is exactly what the customer needs, because this is really an out of the box product. It doesn't care if the air is maldistributed. We typically don't have to do any iterations at all. So it's a self refrigerant distribution balancing design. When you apply it to the product, it self balances. You don't have to go through any iterations. As your air pattern changes, it can also readjust itself. So it's very, very exciting. And probably the most exciting thing, the most important thing with our new evaporator next generation, is this can be used with variable capacity products. So in the past, even if you got a microchannel heat exchanger to work for a fixed speed compressor and it was exactly what you wanted, once you moved away from that particular pumping speed, you started to get maldistribution of refrigerant inside the microchannel. With this next generation evaporator, as you move away from that capacity to a different capacity using a variable capacity compressor, it will again self-balance and readjust and give you optimal performance regardless of what your compressor pumping capacity is. So this is a huge breakthrough for microchannel evaporators, being able to use them with variable capacity applications, because that tends to be the direction that most customers are going in order to meet the new efficiency requirements.
Yeah, and I think we've talked on the show many times about the importance of variable speed applications and these variable volumes, and being able to adapt to different load conditions. Having this being important for indoor air quality, for all manner of applications, including efficiency and meeting new standards. I mean, this is just it seems like a great breakthrough here. And that leads me to kind of my last question. You've talked about what's coming out now. What can we expect from your group, Danfoss Microchannel, in the coming years?
Yeah, so we do have some longer term projects that we're always working on. I think the most important one is we currently apply for outdoor heat exchanger surfaces. We currently operate those above freezing conditions, so above ambient freezing conditions, which of course means that when you want to operate a heat exchanger as a heat pump, so when you're operating below freezing conditions, there's a different set of challenges that you have to overcome in order to do that. So we're working on a heat pump surface that we're pretty excited about. So again, that'll be another game changer where now we're applying microchannel into condensers and then indoor evaporators, and being able to do that ultimately in outdoor heat pump or outdoor evaporator surfaces will be huge for our customers, mostly because they're using a mixture of technologies today where they really like microchannel. They want to use microchannel as much as possible, and we're giving that to them for the majority of their applications. They also would like to transition from tube and fin to microchannel and heat pump applications. So that's one of the products that we're working on. We're also looking at integrated products. So Danfoss is a supplier of many products, and I think a lot of our customers know that. So we have the benefit within Danfoss of working with our colleagues. In this case, where we're developing an integrated heat exchanger plus expansion device. So where Danfoss is providing expansion devices as a separate component in lots of applications like rooftop applications, potentially residential applications, where we can just again have just a plug and play product where the customer can take the evaporator coil. They can just put that directly into their product. They don't have to add the expansion device because it's been integrated into the microchannel heat exchanger. We're pretty excited about that. So that's an ongoing project that we're wanting to even sample as early as this year or 2023. And then one thing that I think is kind of interesting about microchannel, because we talk a lot about heat transfer. That's what its function is. One of the things that we focus on just as much as heat transfer is material science. As an aluminum heat exchanger, there are lots of different aluminum alloys that can be used, and we're always trying to balance between cost and performance and corrosion resistance. Outdoor heat exchangers have to operate in some pretty tough environments, whether it's seacoast, industrial, even agricultural, where fertilizers and different chemicals are used that can attack materials. So as a aluminum alloy product, we have to be very sensitive to corrosion applications. So we're always looking at new materials. We're looking at ways to take the tube of the heat exchanger and make that in-house. Interestingly enough, from a sheet of material. So we're taking a sheet of material and being able to form that into a microchannel tube, which is kind of interesting. But that just simply means that we can make that sheet of material out of different layers of material that are engineered to be anti-corrosion resistant. So those are the things we're working on long term, is just really new material systems. And my advice to anyone who is interested in microchannel heat exchangers, please make sure that the supplier that you're using is very strong in material science, because material science is very, very important for the life of a microchannel heat exchanger in the field.
Yeah, I mean, you hit on so much there, and I think it's very important to realize when we talk about these larger trends, whether it be heat pumps or variable speed. Oftentimes what is enabling these larger trends are the individual component technology and the innovations that a company like Danfoss and your group are really doing, whether it be in material science or in heat transfer technology. And all these things kind of add up to being able to transition to electrification at a larger level, to decarbonization of our space heating. So, it really does burrowing down into this level of detail to really enable these future trends.
Yeah, so we think that we're on the cutting edge of the microchannel heat exchanger technology. We've been able to partner with some really great customers, working together to develop the next generation of product. So I think that the Danfoss microchannel heat exchanger fits extremely well into the future needs to be green, to protect the environment, to improve efficiency of products. So I'm pretty excited about the opportunity to work with Danfoss microchannel heat exchangers.
Yeah, I think the future looks incredibly bright here. Well, I think that's a great place to wrap up. Jeff, I really appreciate your time, and thanks for stopping by. Any last thoughts?
Yeah. So if if you want to learn a little bit more, do a little research on your own about Danfoss the microchannel. Probably the simplest way to do it and easy to remember is just Google Danfoss microchannel heat exchangers. You'll find ways to get to the Danfoss website to learn more about it. You can also go to YouTube. And again, you can put in Danfoss microchannel heat exchangers. There are some really good videos that Danfoss has put up on YouTube to show you a little bit about the benefits of microchannel, how microchannel is produced, if you're kind of interested in, wondering how do we make this product. So those are probably the easiest ways without getting into all the www dot whatever, just Googling Danfoss microchannel heat exchangers. That's the best place to start, and you can find a lot of great information.
Yeah, there's a lot of great content out there on the web about this really crucial piece of technology, like we said, is enabling some of these larger mega trends like electrification, decarbonization. So thanks, Jeff, so much for joining us again. I'd like to thank Jeff Tucker, Global Head of Microchannel Heat Exchangers for Danfoss, for joining us. And that's it for this episode of the EnVisioneering Exchange. Don't forget to subscribe to the EnVisioneering Exchange on Apple Podcasts, Spotify, SoundCloud, or wherever it is you get your podcasts. And lastly, if you enjoy this episode, please don't forget to rate, review, and share with your network. Again, my name is John Sheff. I'm Danfoss's Director of Public and Industry Affairs. Thanks for listening. We'll talk to you next time.